All right, welcome to Monday, week 3 today. Um, just a quick announcement, especially for computer majors, but it's open to anyone. We do a fall welcome with our department. We're going to have it at my house this year. So tomorrow evening, 5 to 7-ish, although last time we were playing beanbags a little later than that, but 5 to 7-ish. We'll just have some food and visit at my house while the other faculty there. So you're welcome to join. There's a sign-up sheet that you can click on to see. Just put your name down and if you need a ride or not there. And we'll try to organize rides tomorrow for that. So fill in that if you want to come. Yeah, just simple food. We'll have some salad, some sandwich fixins, some things like that, some fruit. And again, also note if you have any special dietary needs there, we'll work on those too. So yeah, and it's just a nice informal time just to kind of get to know the computer faculty outside of the classroom, see some things. We'll see if Chris brings his kids. Sometimes that's fun if he brings his terrible twins. So things like that. So, okay. What are we doing this week? So this week we get into if-then statements. So again, we'll just be doing the learning material, going over if-then statements today here. On Wednesday, we'll do this advanced ASCII art exercise, which is kind of fun. We actually will take an image and we'll go through that image and convert it to ASCII art with some if-then statements there. And we'll also do this book lookup assignment. Now, one thing we'll see now going into some more of these more complicated assignments is there'll be more than one file there, and you'll have to download or start from a project that we give you there and modify the code for that. We do that for a couple reasons. One, it's pretty typical to in the real world not to be creating a program from scratch. You almost always are taking up some existing code and modifying it there. So that's part of it. Also, it lets us do some more fun examples that we couldn't do if we were coding it all from scratch, and kind of we can work on some advanced features there with and then hide some of the complicated details from you in files or code that you don't have to write for that. So we'll be looking at then we'll also look at some ways to get or download or open up these sorts of advanced projects here. And we'll actually start that today with this sort of stuff. And then on Friday, we'll do the review exercise. We'll start with a review exercise. We'll talk a little bit about the assignment. Again, this is this book lookup assignment for that there. So that'll be our normal week here. So let's go into learning materials and start there. So again, we're looking at if-then statements. I think I'll start with the CIS awesome stuff. And we'll just talk about Boolean expressions and testing. So if we're checking if something is true or false, we're going to use not a single equals, but an equal sign, 2 equal signs in a row there. The computer, we need to kind of differentiate. And so in math, we tend to have just one equal sign. You know, we say x equals 4 there, or 4 equals x. And it just means that is true, basically. In computing, we have 2 different things. We have an assignment operator, which we use a single equals. So if we say x is assigned 4, then we are storing 4 in the memory location labeled x in that variable. So we need something different if we wanted to ask true or false, is X equal to 4? So when we ask if one thing's equal to another thing, we use this equal equals. We also have a special not equals. And I don't know what you learned to do not equals. Maybe you learned a less than and a greater than right after each other for that. Maybe you had an equals with a slash through it for not equals. There are a number of different ways of doing not equals. So think back in your old math classes, did you write it some way like that? So in the computer, we look at the same thing, and we use this exclamation point and an equal sign, which might seem really weird initially, but in computing, the exclamation point is going to stand for not a lot of times. So when we want to say not or the opposite of something, we'll say exclamation point and an equal sign. So this will read as not equals for this. So again, you can watch this video and it kind of walks you through here. And we're just like printing out some values here. So I'm just going to save and run this. So it is printing out. So if we say int, let me bring this a little bigger, age equals 15 and int year equals 14. So again, this is an assignment. Age is assigned, or 15 is stored in age. 14 is assigned to year, or year is assigned 14. So these are, again, our assignment statements here. Now, this is, we're printing off, is age equal to year? So is age equal to year? So this one is either true or false. It'll actually print out true or false. So here, they're not equal, so it prints out false at the bottom here. And in fact, if I just get rid of this stuff and run it this way, it's just going to say false. So that is going to be false. So what if we set year to 15? So year and age are the same. And then we print this out for this. So that'll print out true. So we print out that. It'll print out false the first time, but when we reset it, it'll print out true. And again, we can switch this to not equals. We can say not equals here and not equals here if we want, and run it. So the first time, age, it is true that age is not equal to year. So that'll print out true down here. And then, but when they are equal, if we say age is not equal to year, that's false. So these expressions, when we use an equals or a not equals, are true or false. Now, what we'll see also is the same thing is true, works with the greater than or less than. So we can do things like, what if I print out age less than year, or age greater than year. So again, greater than or less than will be something that's either true or false here. So the equals, the not equals, the greater than or less than, we can actually do greater than, less than or equals, or greater than or equals. We'll see those. Also, and those will be true, false, Boolean expressions. So they're all Boolean expressions in that these evaluate not to a number, but to a true, false statement. So we'll have to use them in special places, in special locations that expect a true, false value, a Boolean value for this. So now you might ask some things about like strings and how we'll do strings. Strings are going to be complicated, and other objects are going to be complicated. And we'll get more into this later, but when we talk about a string, like two, in here they're talking about two objects like two turtles or two strings, and we ask if they're equal to each other. Then we're talking about, do they refer to the same memory location or the same actual object here? So we're not going to be able to use this to check if if the name variable equals Gibbons or something like that. So we'll talk later on about how we have to handle strings and other objects differently for this. Here we're talking about again, less than, greater than or less than, less than or greater than or equals, less than or equals or does not equal. So those are our operators that we'll be working with this week here. So let's go and look at the if-then statement for us. So we'll be using this if-then statement. We'll write it out in Java. We'll say if, and we'll have some Boolean expression, some expression that's true or false. And we'll start with brace here and end with a brace. And then we'll have our statements in between here. So that's what we'll try to write out for this. So if you're in CS principles or took CS principles, you may remember we had if, then, else, or if, then blocks there. So we had these blocks that we had available where we could say if some value is true or false, then we do something here. And often you'll see this writing in, again, in pseudocode and stuff, but we'll mainly be doing this in Java. So I'm going to start with just a little playground here to try out some things. I'm going to do a new project. Unit 3, sandbox. Let's just try this code here. We're going to say if x is greater than 0, then we're going to print out positive. So we'll write that out here. I'm going to make this a little bigger so you can see it, hopefully. If x is greater than 0, then we're going to print out x is positive. So that's our code. Now, in order for this to work, x, has to be a variable. And again, in Java, we have to declare our variables ahead of time and set them up. So we have to do that. So let's make x, it looks like x should be a number. I'm going to make it an integer. I'm going to say int x. And we're going to set it equal to some value here. So we're going to set it equal to 12. And then we're going to ask if x is greater than 0. So again, now that we have it declared, we can run it. Without that, we can't actually run this code. So this just prints out x is positive for that. And again, if we make this a negative number, like -5, it'll say right, yes, it'll say nothing. So it says nothing because it checks if x is greater than 0. It's not, so it doesn't do this. This only happens if it is positive here for this. That's our basic layout for an if-then statement here. Let's look at some of the other stuff. Well, let's jump into the if then else stuff here. So again, here they're showing this if and some Boolean expression, then do it. We're always going to put braces around our in our if statement, and they're required if we have multiple statements. You can technically do this without these braces here. Switch it back here. You can run it that way, but I will always take off points for that. You, in this class, are always required to put in braces around your stuff. And one of the reasons we do that is that every employer that you ever work with will require you to put braces around that there, because it is such a common error out there, and has cost companies millions of dollars because coders have not put braces around there here. So we'll require these braces here. Okay. I'm going to jump into this Think Java code and look at that a little bit. So again, they introduce these relational operators right away. Here's our relational operators. They're looking familiar. Equals, equals, not equals, exclamation point equals, greater than, less than, greater than or equals, less than or equals here. So, and they all have values of true or false. And here's our if then statement. That looks familiar. If x is greater than 0, print out x is positive. So now they're talking about the else here. I'm going to do the else with this one, and they introduce something else here. So I'm going to use the else here. So what if we want it to print out if this is negative? What if we want it to say, all right, now it says nothing. What if we want it to say something? So we can stick in an else here and another brace, and then we can do our system dot out dot print line. X is negative. And we can run that. So now it'll say X is negative. So again, this is either true or false. If it's true, it'll say it's positive. If it's otherwise, it'll say it's negative there. So does this work all the time? Is there you see any problems with this? Yeah, what if we say X equals 0? Is 0 positive or negative in your mind? So in my mind, it's certainly not negative. Is 0 positive? I don't know. That's a good. I don't know. No, you're saying no. It's not positive. It's not negative. It is just 0. Okay. So now it prints off nothing. Well, no, now it prints out it is negative here. So we'll have to figure out how to handle that case there. What if we do if X is greater than or equal to 0 there? Now it'll say it's positive. So if we say greater than or equal to 0, it says positive there. If we just say greater than, it says negative. But we're going to have to add another case in here eventually to try to figure out how to handle this. So let's do this expression. I'm going to take this expression here and try to print that out here. Let's format that. And let's set X equal to 12. It says X is even here. What does this expression do? And how does it come? Does it always say, what if I change this to 13? It says it's odd, and 13 is odd. What about 14? Can it do 14? That's even, and 14 is even here. So how is it handling this? What does this expression do? Well, we kind of skipped over when we're doing arithmetic. So we can do plus, minus, division, and multiplication. And remember when we were first doing those print statements out there, and we talked, you ran into a problem with integer division when we were printing off like 3 divided by 2 there, and you should say 3 divided by 2 should be 1 point something. It would just come up with 1, or like 5 divided by 3 there, which should just be 1 instead of 1.666 or something like that, because it was doing integer division. If you have 2 integers divided by each other, you get integer division. This is related to integer division. This percent sign is what we call a mod operator, module, or remainder operator. It says take x, divide it by this. They use the percent sign because it's supposed to kind of look like a division. It has a little, I don't know. This version doesn't look that way, but on your keyboard, if you look at like above the 5, it kind of looks like a factor. A factor there where you have 0 divided by 0, that sort of stuff. So I think that's why they picked that symbol. It's just another way of showing division here. So but it has the remainder. So we take x divided by 2 and figure out and come up with the remainder. So if we divide something by 2, the remainder is either 0 or 1. And if it's 0, the remainder is 0, then it's even, otherwise it's odd. So this is a nice, interesting way to do, to check if something's even or odd, or this. Okay, so here we're walking through this. They do this. Now here's our example of why we don't want to do, why we always require you to have a brace in here. So if we do this, clean that up. Oh, see, when I hit clean up, it automatically puts the braces in there already. So I got to try to do this without doing this. Again, because this is not going to work like we expected to. So the computer's going to try to fix this there. So if we say if x is greater than 0, print out x is positive, and also print out x is not 0 here. So if we run this, let's see. Interesting. It won't even let us run that. Oh, I know, I'm missing a brace there. Now it will. Okay, now it'll let us run it. Good. Okay. So it is printing this out here, and you think, oh, that's working well. X is not 0 and x is positive. But what if we make this 0 and then run this? What does it now print off here? It's going to print off x is not 0, but x is 0. And the problem is that even though we have this written this way, this is not what is happening. This is what's really happening, is that we have 2 separate statements. We have this statement, if x is greater than 0, print out x is positive. And then it's always going to print off x is not 0. Even if it's 0, if it's negative, it's always going to do this. This statement is not in the if-then statement. Because if you don't have braces here, it assumes that only one and only one statement afterwards is inside that if here. And so that's why it gives you a warning here. It is telling you, to put parentheses here. If I tell this to reformat this code, it'll stick in the braces for me and show me that that's here. And in fact, if I, let's see if I move it up here and tell it, again, it is warning me that this isn't looking good. If I go to source and just tell it to format it, it will kind of clean this up, or it'll, if I need to move this, it'll stick it in there. So this is like what it's showing you is that's why we always require you to put these parentheses or squiggly brackets or whatever, these braces I don't know, what do you call those? So in my mind, so what are our terminologies? So in my mind, these are parentheses, right? These are square brackets. So what do you call these? What? Curly brackets? Yeah. What would you call them? Curly brackets? What should we name? We need to name something in the course. I call them squiggly brackets. I don't know. I think squiggly is a more fun name than curly, but curly brackets is probably what is more common out there. I sometimes call them braces. I was taught to call them braces there because they or again, these are square braces or square brackets, and these are just regular. So again, just be aware there are different forms out there. Okay. Okay, we walked through some of this. Here's another issue that we'll see at times is sometimes when you're typing these things out, you'll type things like you'll type if x is greater than 0, and you'll just get used to hitting a semicolon at the end of each line because you'll often be hitting semicolon. You hit a semicolon, and then you'll do this here. What does this do here? What does that semicolon do? Is that causing any problems? Yes. So it'll say x is positive. So x is 12. If x is greater than 0, print out x is positive. That looks good. What if we make it -5, though? -5 is certainly not positive. And we run this, it's still going to say x is positive here. Why does this say x is positive here? Ideas? Why does why does this one semicolon cause us problems in here? So that semicolon causes us a problem. Yeah, basically it is stopping. Here's our if statement, and it is stopping the if statement says if x is greater than 0, now do all the statements until you get to a semicolon. There are, an end, and it hits the semicolon right away, so it does nothing. So in fact, if I tell this to reformat this, it will move this. It won't indent this. It'll move it back here. So this is often called a short circuit semicolon in your if-then statement because it'll short circuit, it'll cut out your if statement here for it. So we have to watch that you don't accidentally. It's syntactically okay. You could technically put in an if-then, a semicolon there with the rules of grammar, of our language. It is allowed, but it is not. There's probably no time where you ever want to actually do that here. So you want to do this. And that's one thing I suggest often. And when you turn in programs, I want you to do that, is to clean it up. I almost always recommend you go to source format and reformat stuff because that'll sometimes catch these things for you with this. So they're talking about this incorrect sum. And again, talking about this empty statement here, that sort of stuff. So. Now we talked about this, and I'm just going to mention it today. We're going to do it more next week. So this week we're going to try to stick with relatively simple if-then statements. Just get used to them. Next week we'll start. Well, actually, yeah, this week we'll start chaining together. I guess next week we're going to do compound if-thens statements with this. So we'll look at different ways of doing these. One way is you can say if, and then you can say else if, and chain together a bunch of if-then statements. You can also do things like, let's do this. We're trying to do if X is positive, we did an else, but we could do it this way here. We could do if X is greater than 0, say it's positive, and then we could add if X is less than 0, then we're going to say it's negative. So we can have just two separate if-then statements. It'll say negative there. And if it's 0, it won't show anything here yet. But we could add another statement here. If X is equal to 0, then say X is 0. So we can do that. We can have a whole series of separate if-then statements here, one right after the other. So we're going to be, we're going to set X equals some value. If X is greater than 0, print it's positive. If X is less than 0, print it's negative. If X is 0, print it's 0. So again, we can just kind of stack these ifs as separate ifs. Now they're not chained together. We're not using an else or anything in there. We're just having one if after another if after another if, and we can put as many as we want here. We can also put these generally in any order. If I want to move this up at the top, that works out fine. Doesn't matter what order we have these in. I can check these out here. And again, we'll get into more complicated things next week, including the switch statement for that. So I'm going to leave that to next week. Okay, so let's dive into some more examples. So we're going to do this driving age example. Chris has a nice video of this, so we'll walk through the same one here. And program this. So I'm going to just do it in my little sandbox area here. Ask the user to enter their age and read it in as an integer. So we're just going to do system.out.println. What is your age? I'm going to declare a variable, an integer, call it age here. And we're going to read it in from a scanner. So we're going to need a scanner. I'm just going to grab, I'm getting lazy, my scanner declaration from this other program, paste it in there and do the import here. So I have my scanner ready to go. So now I'm going to go input dot next int. Read in the next integer. So what is your age? Read that in to my age variable. Okay, ask the user to enter their age and read it into as an integer. I did that. Check if their age is more than 15, and if so, display you can drive. So let's do that. If age is greater than 15, then I'm going to start a bracket and say system.out.println. You can drive. Now I'm going to run this. I'm saying, I'm only 12. Can I drive? And it's going to say, you can drive. Doesn't seem right. So where did I go wrong here? If I enter 12, it should say you can drive there. Scanner, print out your age, int age. If age is less than 15. I want it. What did we say? If the age is more than 15, I did less than. So I want to check if age is greater than 15, then you can drive. So let's try that again. 12 doesn't say anything. Okay. 16, you can drive. Okay, and then it says add in the you cannot drive yet otherwise. So again, if they run this and they are 12, it doesn't print out anything. So I want to print out something. So I'm going to, so I could just use the system.out.println here and do this, you cannot drive. Is that going to do what I want it to do? Here, so let's try that. If I run this and I enter 12, so you cannot drive. That looks good. But I need to test out multiple conditions. What if I try and run 16? Your age is 16. It says you can drive, and then it says you cannot drive. It says them both. So how do I get this so that it says out, it either says you can drive or it says you cannot drive. It won't say both of them some of the times. So how do I want to set that up? So that's where our else comes in. I want, if the age is greater than 15, I want to print this out, else I want to print this out. And so I'm going to need an else in here. And I'm going to put this statement in my else. I'm going to move that up here. So now, if I type in an age of 16, it says you can drive, and that's all. If I run it and I type in my age is 12, it says you cannot drive. I'll just warn you, I start getting confused with all these braces that are wrapped up. And if I click on them, it does highlight them. But I often start commenting out on these braces so I know what is what. So I often put a little comment here. This is the end of the else. This is the end of the main. And this is the end of the class. In fact, my more complicated or professional IDEs that we use often put those comments in for us there, so we don't have to do that there. Sometimes you'll see editors which will put in these comments automatically for you, which is sometimes nice. And often, I don't know if you can turn these off and on sometimes in your settings. I don't know if you can with NetBeans. Yeah. Okay, so that's our stuff. Next, I'm going to add checks for a learner's permit. I'll just warn you. So Chris's kids are, like 5 and 6. He has no idea what age you can actually drive. And he lives on a farm. I think his kids are already driving the tractor around the farm already. So I would not trust Chris's ages in here. So do not use this as fact in Minnesota. Okay. So just because Chris says you can drive when you are 13 or something doesn't mean it's true. Okay. So I'll just warn you. Okay. So, okay. We're gonna check if their age is exactly 15. We're gonna say you can drive with a permit. Otherwise, we're gonna say you cannot drive yet. Okay, so how are we going to do this here? So we've got if you're more than 15, you can drive. Otherwise, you can't drive. On this, maybe I can just add another if then if they're 15. If their age is, and I have to remember to do the equals is exactly 15, then I'm going to say you can drive with permit. You can drive with the learner's permit. So if it's exactly 15, you can drive with the learner's permit. Otherwise, you can, if it's greater than 15, you can drive. Otherwise, you cannot drive. So is this going to do what I want it to do? So if I run this, and I enter my age, here, let's say I enter 16. So you can drive. That looks good. Run this again, enter my age, 12. Not, 23. It's not quite. We'll try it again. 12. So you cannot drive. That looks good. Now I'm going to enter 15 exactly. And when I enter 15, it says you can with a learner's permit, but then it also says you cannot drive yet. So why does it say both of those when I have this else here? So I'm saying if x is equal to 15, then print this. And if x is greater than 15, print this, else print this. So why does it print off both of these? Yeah, I have two separate if statements. I have an if statement up here and an if statement here. And this else only ties into this if statement. So I can just move this else statement up here. How's that sound? Will that do what I want? Oops. So now, if they're 15, you can drive with a learner's permit. Perfect. If I'm 12, you cannot drive. If I'm 23, it says you cannot drive yet. And then it says you can drive. So that moving the else statement up there, again, it's part of, now it's part of this if statement and this if statement. There's two separate if statements here. And that's not what I want. Okay, so I'm going to move it back. What I want to do is chain these if statements together in some way. So I'm going to say if the age is 15, then do this. And then I'm going to say else if. Else, and then put the if. Else if their age is greater than 15, do this. Else, do this. So with a chain of these, if, else, only one of them will occur. If this is true, we'll do this. Else, if this is true, we'll do this. Else, if nothing above is true, then we'll do this stuff. So this is what we want, is a chain of if-then statements for this. So now we'll test this up. What is your age? 12? You cannot drive it. Okay, that's good. 23, you can drive. Now 15, you can with a learner's permit. Okay. Maybe I should say you can drive. Okay. So it only prints off one of those things for us. So we can also look at this from I do one more. If you're a 14-year-old, you can drive with a farm permit here. So we're just going to make that up, apparently. So Do they still have farm permits? Anyone grew up? No? Yeah. But did you drive your pickup truck on the farm when you were 12?
When I was 15.
15? Okay.
My brothers were.
Okay. Yeah. So, all right. So let's add that. How do we add that in here? And this is where it gets kind of complicated here. Is trying to get we're checking if the age is 15, do this, else if the age is greater than 14, do this. So where can I put this? Maybe I can put this right here. I'm going to add an else if. And again, this is where sometimes if you have these set up as separate ifs, it works. You can put them in any order, but sometimes the order is important. So what if I check right here if else if the age is less or is greater than 14, do this. So you can, I'm going to do this. You can drive with a farm permit. So if their age is equal to 15, you can drive with a learner's permit. Else, if the age is greater than 14, we can say you can drive with a farm permit. Else, you can drive. Otherwise, you cannot drive. What is that going to do? Again, it's listed in these if then else's. I'm going to, so only one of them should occur. So again, if I'm 12, you cannot drive yet. That's good. If I'm 14, it says it's supposed to be yes. Is it check if 14 years or old? So maybe I wanted to do this if age is greater than or equal to 14. And then maybe, and do it that way. So let's try that. Okay, all right, let's get 12, can't drive. 14, I can drive with a farm permit. 15, I can drive with the learner's permit. That's looking really good. 16 isn't going to work. So if I try 16 here, it says you can drive with a farm permit when I'm 16. Oh, darn. I was so close. So why is that? So how do I fix that? What is causing it? So again, it's going through this in order, right? It's checking if you're 15. Then it's checking if you're over 14. And so if you're over 14, you know, if I say I'm 60 years old, it says I can drive with a farmer's permit here. Because anyone who's over 14, this will occur, and then we skip over the rest of this. So I need to kind of set these up in a certain order or work these out, or else maybe I can just check. I shouldn't maybe be checking if the age is greater than or equal, but maybe just equals to 14 here would be one way of doing this. Or I could set this up in a different order. I could do this. Let's see if I can do it in this order. Check if they're 15, then check if their age is greater than 15, then check if their age is greater than or equal to 14, then assume if none of those can say you cannot drive. So start in this order. So if I do it in that order, I think it'll work. So 12, can't drive. 14, farm permit. 15, learner's permit. 16, you can drive. 60, you can drive. So we have that set up there. So you can do it. So again, sometimes the order of this helps or is important for this. So if you didn't program this in, but you want to download these files, there are solutions here. And I'm going to walk you through how to do this in a couple different ways, because this is kind of be the same thing we do for the assignments here. So one thing I'll do is I will just have a link to bring up the code. So if I just click on this link, it'll just show me the code here. And this is good if I just want to copy this code and paste it in here, something like that. This looks similar. Let's see how similar this was to what we were doing. Print what's your age, read that in. Check if the age is greater than 15, you can drive. Else, if the age is 15, you can drive with a permit. Else, if age is 14, you can drive with a farm permit. Else, you cannot drive. So again, this one starts with the oldest, then the 15 and the 14, and they're just checking if they're equal to that, and then finally prints off you can not drive. So again, that's I'll generally we link to the code here, but you can't. How do I I'd have to make a new project here. So let's look at this way, GitHub download. So GitHub is this cloud-based system for sharing code and monitoring code and tracking all your changes with code. So if I click on here, I think you should be able to view this even if you don't have a GitHub account here. So now I can take this URL here and I can do this. What I want to go to team git clone. So in NetBeans, I'm going to go team git clone, and it's going to want the URL. I'm going to paste in my URL here. I'm going to not worry about the password because again, it should be open to everyone here. And I'm going to go finish. It should have, oops, yeah, it's opening up. The project was cloned. Do you want to open it up? I say, yeah, open that up. So it'll be, where is it? Here, it's right at the top, this driving age master program here. And under source packages, here's my driving aid. So here's the program there. So again, you can just take this link in GitHub and then you go to team git clone, team git, oops, now that I'm already there, I'm already in a project that's already been cloned. It won't let me do that. But if I go to a different project here, I should be able to go to team git clone. Okay. So that's one way of doing it. Another way that people like and find useful is just with the zip file. If you're used to doing zip files, this is a nice way. I can download this zip file. It's going to download this zip file. It saves it in my download folder. I can go there. So a zip file is a bunch of files and folders all pushed together into a single file here, and it's zipped up. Now, I can right-click on that and open it up and look at it, but it's still zipped, and so I can't open it up in NetBeans. So what I want to do, what I have to do, is I have to unzip it. See, and if you look at the symbol, it still has a little zipper along it. So I'm going to click on it, and I'm going to do extract all, I think, here, and say extract. So now it'll extract it all there. Okay, now I can go back to NetBeans. I can go File, Open Project, and I save this. Save this in my downloads. For some reason, downloads isn't showing up there. Let's go to I'm going to go to desktop and then downloads, and there it is, driving age. I'm going to open up that project, and it'll open it up, and I can look in there for this. So in these, there's just a single file. I can just give you that file. But again, for the learning activity on Wednesday, there'll be multiple files here. And then for the assignment, also there'll be multiple files. So you'll have to do it one of these ways for this stuff. Okay. So we'll do one of these ways for the assignment or in the learning activity this week. Questions on that? I like if statements. I like that logic and thinking of that. I'm not really good at that. Like my wife's really good at doing logic puzzles, where they have all these things and you have to figure out all these different conditions in these logic puzzles. And if this is true, then you can assume this is, and if these three are true, then the only thing left is this sort of stuff. She's very good at those. Me, not so much, but I do like simple if then stuff like this. This makes sense to me. So we're going to do another one with a series of things. Chris has a nice letter grading example here, which I think is quite good. But there's a nice video and the code's already here. So I'm going to leave that for you to watch. We're going to do the wardrobe planner example here that I just added this year for this. So I'm going to do, how much time we got? Just a couple minutes left. Let's see if we can do this. Okay. I'm going to go File, New Project. Unit 3, wardrobe. Okay, create a program tells the user, ask the user to enter the outside temperature here. So I'm going to go system.out.println. What is the temperature? You're outside. And I'm going to read that into a variable. Maybe a double. Will they enter a decimal or just an integer? You're saying integer? Okay, we're going to go integer. Integer temperature equals. I need my scanner here. So again, I've got to do my scanner input equals new scanner system in. How's that look? It's hard for me to type all that. In my other IDEs, I just start typing the first line or something like that, and it would fill it in automatically. But we like to have you type this stuff. Okay, system.in. I think that looks right. And now I can do input.next int. And again, if you want to do double, you can do that. Just do. Okay, so I have my temperature now. What do we want to wear? So if it is below 0, it's not below 0 yet. It's so nice outside now. So if it's below 0, we want to wear a heavy winter coat. So we want to say that. If the temperature is less than 0, then I'm going to system.out wear a heavy winter coat and mittens. Now, if the temperature's between 1 and 32, so I'm just going to say now if the temperature is less than 32, let's say less than or equal to 32. Then I'm going to say, I'm just going to copy that. Wear just a coat and gloves. I should be reading what it says in here. Yeah, coat and gloves. Now I'm just going to copy that whole thing and say, if the temperature is less than 50, I'm going to say, wear a jacket or hoodie. Okay. Now, before I go too far, I want to test this out, see how I'm doing here, because I'm not doing really well. So let's try this out. You see my mistake? What is my mistake here? So what's the temperature outside? Oh, it's -5. So if I say it's -5, it says wear a heavy winter coat and mittens, wear a coat and gloves, and wear a jacket and hoodie. Well, that kind of makes sense. I like to wear layers when it's cold out. So this is telling me to wear layers. But this is not what I wanted it to do there. So I wanted to do this or this, else this. And so I want to chain these together, I think. So I want to say if this is true, else, if this is true, else, if this is true, and keep going. And eventually I'll have an else. And I'll say this. Okay. So now it should just, so if it's -5, it'll just say one thing. And if it's 45 degrees, it'll just say one thing. I think I'm still missing one in here, right? I'm missing the 70s. It's less than or equal to 70. Then I want to say this. This is my probably September and October, my favorite weather out there. I like this where you can wear just a fleece, long sleeves, and then when it gets sunny out, you can just have your t-shirt, short sleeves on and stuff like this. I like this weather. It's one of my favorite weathers. Okay. So you can try out these. Wednesday, we'll be doing some more of the examples and review stuff for this. Questions on this? Nice to see we have an online student today. Hey, Mick. I'm going to wrap up here.